Question 7, we have a small particle hanging on the end of a light string, 2 meters long, we can see here. Position 1, position 2. So the least speed, so what that means is as it gets to D, it's slowing down and the tension in the string will become slack. So we can say that the tension up here, T2 is 0, and we'll have the tension at the bottom, T1 is equal to, in terms of T1. So let's start this question by looking at our energy. Let's look at position 1, mgh plus a half mv squared. So mg by 0, if we take here as our starting point, the height is 0, plus a half m by u squared, our initial speed. It's just going to give us a half mu squared, or mu squared over 2 for position 1. For position 2, mg, well h will be 4, 2 plus 2, plus we don't know the speed as it gets there, a half mv squared. So position 2 is going to be 4 mg plus a half mv squared. If we multiply by 2 and divide by m, we get u squared is equal to 4g plus, not 4g, 8g plus v squared. Be careful not to make silly errors. We'll need some part of this, probably velocity. Velocity is equal to u squared minus 8g if we need it in terms of u or v. Now let's look at our forces. So at this position we have T1 towards the center and mg. So we're going to have T1 minus mg is equal to the centripetal force, mv squared over r, mv squared over 2. So 2T1 minus 2mg is equal to mv squared. So we have v squared above. We don't have mv squared, but we could have subbed it in. Well, let's leave it like this for a second. Our second equation at the top then. At this point we have mg towards the center, mg. We also have T2, which is going to be 0 at the least speed, so it just makes it there. It's going to be mv squared over 2 over r, so mg in this case, mg is equal to mv squared over 2. So v squared will be equal to 2g if we divide by m. So the velocity involved here is the square root of 2g. So what are we asked for at the least speed? So we're looking for u, so we need this one. U squared is equal to 8g plus v squared, which we have here is 2g. So u is equal to the square root of 10g, 10, 9.8, 98. This is 9.9, correct to one decimal, meters per second. Then we're told that if the speed is 7 meters per second, find the angle the string makes. So let's say it gets to here. Find the angle the string makes with the vertical when it goes slack. So that's the angle it makes with the vertical. So it's this angle in here. So let's do our forces diagram. So we have mg coming down. We have my angle A. And if we make mg the hypotenuse, I have my right angle here. My A towards the center, I have mg cos A. And I have tension in the string, but it's going to go slack. So I'm going to have mg cos A plus t, but it's going to be 0, will be equal to mv squared r, which is mv squared over 2. And if I take my position, it's going up 2, and then this is 2, so this is 2 cos A, so it's risen 2 plus 2 cos A. So mgh at the start plus a half mu squared is equal to mg 2 plus 2 cos A plus a half mb squared. So with these two equations, we should be able to solve. So here we have mg cos A. Tension string is going to go slack is equal to mb squared over 2. So g cos A is equal to b squared over 2. 2g cos A is equal to v squared. We could leave it as v squared over 2 if we want to sub it in here. But let's sub 7 in for u. So we're going to get 49 m over 2. Divide by m here as well, couldn't we? Let's do that at the start. Let's divide by m. So 49 over 2 is equal to 2g plus 2g cos A plus, well, what would v squared over 2 be? It would be g cos A. Don't need to worry then. So we're going to get, if we get it in terms of cos A, we have 3g cos A is equal to 49 over 2. Well, that's 49 over 2 is 5g over 2. 5g over 2. Does that work? So we have to bring across the 2g. That will be minus 2g. If I multiply by 2, I'm going to get 6g cos A is equal to 5g minus 4g. Dividing by g, I get 6 cos A is equal to 1. So cos A is 1 over 6, which would give an angle of 80.41 degrees.